Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Perhaps it's been a long day, full of noise and movement, and now you're ready to drift, to let your thoughts quiet, your body soften, and your mind wander far beyond the world you know. There's nothing you need to do now but rest. Breathe slowly. Let the air flow in and out like the tide of a gentle sea. Because tonight, we're traveling into one of the universe's most mysterious places, the realm of black holes. Together, we'll explore 100 sleepy facts about every kind, from the smallest stellar hearts to the ancient giants at the centers of galaxies. We'll listen to their silence, their power, and their beauty, discovering how the cosmos folds itself into shadow. If these calm journeys help you rest, consider liking and subscribing. It helps other dreamers find their way here too. Now, close your eyes and let's begin. Fact 1. The quiet collapse. Long before telescopes could see the heavens clearly, the idea of a star collapsing under its own weight was only a whisper in human thought. A black hole begins when gravity wins, when a massive star burns through the last of its fuel and can no longer hold itself up against its own pull. Its light fades, its heart tightens, and the core begins to fall inward, endlessly. It doesn't explode outward, it folds inward, a calm, unstoppable surrender. In that final moment, the boundary between matter and nothing blurs, and the star becomes a place where time itself slows to near stillness. Beyond this quiet collapse, new forms of gravity begin to take shape. Fact 2. The star that fell inward. Imagine a star 10 times the mass of our sun, blazing for millions of years. Its light warms nearby worlds. Its fusion heart keeps balance. But eventually, even the brightest star grows tired. Its core runs out of elements to burn. Without that outward pressure, gravity begins to whisper, "Come home." The outer layers fall inward, crashing against a shrinking heart. The core grows denser than imagination allows, until not even atoms can resist. What was once a sun becomes a silent singularity, invisible, yet infinite in pull. In its place, only darkness remains, surrounded by the ghostly echoes of light that once was. And from that silence, the story of the black hole truly begins. Fact 3. When gravity wins. In every star, two forces are at play: the outward breath of fusion and the inward pull of gravity. As long as they balance, a star lives, glowing in steady equilibrium. But when the fire fades, gravity claims victory. Slowly, delicately, it begins to crush everything toward the center. No explosion now, no light, only collapse. The atoms themselves lose their structure, becoming a single dense point. Space curves around it like fabric drawn into a knot. And from that knot, no light can escape. The star that once shone across, space becomes a quiet, invisible well. Beyond it, another mystery waits: the moment when time itself begins to change. Fact 4. The heart of a dying sun. Every black hole begins with an ending. When a star many times the mass of our sun reaches the last stages of life, it burns its fuel faster and faster, like a candle flaring before it fades. The outer layers tremble, the core compresses, and for a fleeting instant, the star resists its fate. Then it collapses inward, and the outward brilliance gives way to silence. In that still center, matter is squeezed beyond comprehension, forming something so dense that space itself curves around it. The heart that once glowed with fusion becomes a doorway, a well of gravity deeper than any mind can truly imagine. And from this quiet death, a new kind of existence is born, one made not of light, but of its absence. Fact 5. The point that holds infinity. At the center of every black hole lies a mystery beyond all equations, the singularity. It's the place where our understanding ends, where physics loses its footing. In theory, it's an infinitely small point of infinite density, where all the mass of the fallen star is gathered into something dimensionless and absolute. Time, space, matter, all flow toward it and stop. The very laws that guide galaxies and atoms no longer apply. Some say it's a tear in the cosmic fabric, others, a seed of creation waiting to bloom again. But no light, no signal, no story can escape from that point. Only silence, stretching across eternity. And around that silence, space begins to form its shroud. The event horizon. Fact 6. The birth of the first black holes. Black holes are not only the children of dying stars. Long before our sun was born, in the first billion years after the Big Bang, the universe itself made them. Great cosmic seeds formed from collapsing clouds of gas. These were the first black holes, vast and ancient, growing in the young galaxies like hidden hearts. They swallowed starlight and dust, merging, expanding, becoming the titans we now call supermassive black holes. In the early darkness, they shaped the cosmos, guiding galaxies to form around their immense gravity, pulling stars into orbits that still spin today. Even now, their presence hums through space, reminders that creation and destruction often begin in the same breath. Fact 7. Shadows in the early universe. In the first ages of the cosmos, when galaxies were still learning to form, the universe was dim, filled with hydrogen fog and soft radiation. Amid this quiet haze, the first black holes appeared like ripples in the fabric of creation. They were small at first, born from the collapse of the earliest massive stars. But the young universe was generous, rich with gas, dust, and time. These shadows fed, grew, and merged, shaping the galaxies that would one day shimmer across the night sky. Every spiral and cluster we see today carries the imprint of their early hunger, a quiet reminder that darkness too can be creative. And from those ancient shadows, new stars found the paths they still follow. Fact 8. Cosmic seeds in primordial clouds. Before galaxies had arms or names, enormous clouds of gas drifted in silence. Within them, gravity began to whisper, drawing matter inward, forming knots and cores. Sometimes, those clouds collapsed so quickly that no stars had time to ignite. Instead, they became black holes directly. These direct collapse black holes might have been the ancestors of today's supermassive giants. Born without starlight, they grew in darkness, swallowing the gas around them and anchoring the galaxies that would form later. Their presence turned chaos into structure, giving gravity something to gather around. It's a gentle thought that even in the deepest dark, something stable was quietly taking shape. From those unseen seeds, the cosmos learned how to grow. Fact 9. The collapse of the first stars. The first generation of stars, called population 3 stars, were enormous, brilliant, and short-lived. They burned pure hydrogen and helium, their lives measured in cosmic heartbeats rather than millennia. When their fires faded, they did not simply fade away. They imploded. Their cores collapsed, creating some of the first stellar black holes in existence. Though those ancient suns are gone, their remnants still influence the universe. They became the anchors of galaxies, the triggers of new star birth, and perhaps the origin of black holes that would grow to unimaginable size. So even the earliest light in the cosmos left behind a shadow, and in that shadow, the pattern of everything yet to come. Fact 10. A universe that learns to breathe. In time, the young universe began to settle. Galaxies spun themselves into form. Stars shimmered into constellations, and around their centers, black holes grew, steady and silent. They became part of the cosmic rhythm. Inhale as matter drifts in. Exhale as radiation and jets flow outward again. Every galaxy found its balance in this dance of gravity and energy. Without black holes, galaxies might have scattered apart, their stars unanchored. But with them, the universe learned how to breathe, expanding and cooling, then pulsing with new light. Even in the vast silence, there was pattern, a calm order rising from chaos. And at the heart of that order, the black hole waited, quietly shaping the future of stars. Fact 11. What a black hole really is. A black hole is not a hole at all, but a region of space-time where gravity becomes absolute. It's a curve in the universe so deep that not even light can climb out. Every bit of mass, every particle, every photon that drifts too close is drawn inward and never returns. Yet the black hole itself isn't solid. It has no surface, no crust or core in any ordinary sense. Instead, it's defined by its event horizon, the invisible boundary marking the point of no return. Inside, everything that once had form is drawn together into the singularity, the place where matter and time dissolve into mystery. What we call a hole is really a place where the rules change, where space itself folds inward like a sigh. Fact 12. The event horizon's silent edge. If you could drift close to a black hole, slowly, safely, as if in a dream, you'd see nothing sudden. There's no barrier, no wall to touch. The event horizon is invisible, a threshold marked only by what can no longer escape. Light stretches, reddens, and fades as it tries to flee, slowing until it seems frozen at the edge. From a distance, it's like watching time stand still, the universe caught in a quiet pause. Inside, the fall continues forever, though to an outside observer, nothing seems to move at all. It's the softest boundary in existence, not a wall, but a vanishing point. Beyond it lies silence and the heart of the unknown. Fact 13. The singularity within. At the core of every black hole lies what we call the singularity, a word that sounds simple, but hides everything we don't yet understand. It's the point where matter is crushed into something infinitely small, where density grows beyond measure, and the laws of physics can no longer describe what happens. Inside that impossible point, time and space exchange their roles. What was once movement through time becomes a journey through space, and all paths lead inward. We can't see it, touch it, or even imagine it clearly. But the singularity is the quiet center of cosmic gravity, the still heart at the bottom of an endless fall, and around it, the universe bends softly, like fabric drawn toward a pin of infinite weight. Fact 14. Time slows to a whisper. As you drift closer to a black hole, time itself begins to change. From far away, clocks tick normally, stars move, and moments pass. But near the event horizon, seconds stretch like shadows at dusk. A minute outside might feel like 1,000 years for the one falling in. This is called time dilation, a gentle consequence of gravity's deep pull. The closer you get, the slower your time moves compared to the universe beyond. If you were to watch a falling traveler, you'd never see them cross the horizon, only fade, slower and slower, until they seem frozen in place. To the traveler, though, the fall continues smoothly, into quiet, into lightless infinity. Time becomes a whisper, fading into the dark. Fact 15. Space itself bends and folds. Einstein once described gravity not as a force, but as the shape of space. Imagine the universe as a great sheet of silk, smooth, soft, and endless. A star rests on it, and the fabric curves gently around its weight. But a black hole doesn't just bend the silk, it draws it inward, folding it so steeply that every nearby thread curves toward the same invisible center. Light follows these curves, wrapping around the hole before vanishing in. From afar, we see a distorted halo, a soft ring of bent light glowing around a circle of darkness. It's not a wound in space, but a perfect curve, a quiet spiral where geometry itself falls asleep. Fact 16. The gravity well without a bottom. A black hole is the deepest well the universe can create. Imagine a slope so steep that everything which begins to slide can never climb back out. That's what a black hole's gravity is, a descent without end. Even light, the fastest thing known, cannot escape once it crosses that silent boundary. The deeper the fall, the slower the climb back to freedom. And yet, from far away, this immense pull feels smooth, patient, almost serene. It doesn't tear space apart violently. It curves it inward, softly but completely. The universe accepts the shape without protest. To fall toward a black hole is to surrender to gravity's most peaceful command. Come closer, closer still, and never return. Fact 17. Where light fails to return, light, too, feels the gentle lure of gravity. When it passes near a massive star, it bends. But near a black hole, it bends so far it can circle the void again and again, forming rings of ghostly brilliance before finally vanishing. What remains is the shadow, not a true absence, but the mark of all the light that tried to escape and couldn't. Astronomers call this the black hole's silhouette, and it's what we've begun to see through the eyes of powerful telescopes. It's not the hole itself we see, but its edge, where light gives up and fades into quiet. A circle so dark it defines the limits of vision, and beyond that circle lies the unseen. Fact 18. The geometry of darkness. Black holes are not chaotic monsters. They are, in truth, elegantly shaped. Their geometry is simple, even beautiful. A perfect sphere of influence, defined by mass and spin. Around this sphere, space-time curves in precise harmony, like ripples around a smooth stone dropped in still water. Mathematicians describe these curves with equations that hum with balance and symmetry. Einstein's field equations, complex as they are, yield something calm, a structure of pure order. The deeper you study a black hole, the more graceful it becomes. It is not a place of chaos, but of perfect geometry. And within that geometry, time and light trace the outlines of infinity itself. Fact 19. The warping of time's flow. In the universe, time is not steady. It stretches and curves wherever gravity deepens. Around a black hole, this warping becomes extreme. Seconds slip differently there than they do among the stars. For someone watching from afar, the fall toward a black hole seems endless. For the one falling, it's instant and smooth. It's as if each heartbeat slows, then disappears into silence. To the traveler, the horizon rushes up. To the observer, it never quite arrives. This strange divide reminds us that time is not a single thread, but a woven fabric, bending, folding, and rippling with the weight of the cosmos. Near a black hole, time doesn't end. It simply drifts, slower, softer, quieter than anywhere else. Fact 20. The soft boundary, between being and nothing. Every black hole hides behind an invisible veil, the event horizon. It's not a surface one can touch, but a region where escape becomes impossible. Anything that crosses it is cut off from the rest of the universe forever. Yet this separation isn't violent. It's strangely calm, like stepping into deep water and watching light fade above. Inside, time and space trade places. Moving forward in time means falling deeper in space, pulled toward the singularity. Outside, everything continues as before, unaware of what's been lost. The horizon marks that delicate edge, where presence becomes absence and existence drifts into the unknown. In the silence there, the cosmos whispers its most mysterious truth. Even nothingness has shape. Fact 21. The fate of massive stars. When a star several times heavier than our sun reaches its final breath, it cannot die gently. Its fuel runs out, its light falters, and gravity surges inward. The core collapses, while the outer layers explode outward in a brilliant supernova, a last, bright sigh. What remains behind is dense beyond comprehension, a neutron star, or, if massive enough, a black hole. This transformation happens in seconds, yet it reshapes space forever. The star's identity vanishes, but its gravity remains, a silent monument to what once shone so brightly. It no longer radiates light, but it still holds its place in the grand pattern of the cosmos. Every black hole begins this way, not as destruction, but as quiet continuation. Fact 22. Collapsing hearts of giants. When the mightiest stars exhaust their fuel, their hearts begin to collapse under their own immense weight. Hydrogen turns to helium, helium to heavier elements, until fusion can go no further. At that point, gravity has no opponent left. The core folds in upon itself, compressing to a point smaller than imagination allows. The outer layers erupt outward in a blinding supernova, scattering elements that will one day form new worlds. But the heart remains, shrunken into a well of infinite gravity. This remnant, only a few miles wide, yet more massive than our sun, becomes a stellar black hole. Where once there was brightness, now there is only calm darkness, a star's final, quiet sigh into eternity. Fact 23. The quiet end of supernovae. A supernova is one of nature's most dazzling goodbyes. For a brief moment, it outshines an entire galaxy, casting light across billions of miles. But the beauty fades quickly, leaving behind stillness and the ghost of what was. Inside that fading glow, the core collapses deeper and deeper until it passes the point of no return. What follows isn't noise or chaos. It's silence. The shock wave moves outward while the heart becomes invisible, vanishing into its own gravity. Astronomers can only infer what happened by watching how nearby stars and gases move, their orbits bent by something unseen. The death of a star, then, becomes the birth of a mystery. And somewhere within that silence, gravity holds its breath. Fact 24. The invisible remnants. Most stellar black holes are nearly impossible to see. They emit no light, no visible trace of their presence. Yet, they reveal themselves through the company they keep. Stars that orbit nothing visible, gas that glows faintly as it spirals inward and heats before vanishing. This gentle glow is called accretion radiation, the last light released before matter disappears forever. We can watch these signals like whispers on the edge of vision. By tracing them, astronomers map the unseen, revealing the quiet power hidden among the stars. Each invisible remnant is a story half told, a sun that lived, burned, and fell inward, now resting in perfect stillness. They are the quiet watchers of the galaxy, unseen but always there. Fact 25. Black holes that wander alone. Not every black hole has a galaxy center to call home. Some drift quietly through the star fields, unseen and solitary. These rogue black holes were born from collapsing stars or flung away by gravitational encounters. Silent travelers crossing interstellar space. They move without light, without sound, disturbing only what passes too close. A distant star might brighten for a moment as its light bends around them, revealing the traveler's presence like a soft footprint in the dark. Otherwise, they go unnoticed, wandering endlessly through the Milky Way's hidden corridors. To imagine one gliding past, quiet and unseen, is to remember how vast space truly is, and how small, yet connected, our glowing sun really feels. Fact 26. Found in pairs and clusters. Some black holes are not alone. They are born within binary star systems, where two massive suns once orbited each other in a gravitational dance. When one collapses into a black hole, the other may continue to circle it, bound together in silence. The living star sometimes feeds its invisible companion, gas drifting from one to the other, forming a glowing disk of light and heat. These cosmic pairs emit soft X-rays, the only sign of their shared existence. In the densest star clusters, many such pairs may dwell together, a quiet community of collapsed hearts surrounded by the ghosts of their pasts. In their slow orbiting, there's a strange harmony, as if even in darkness, companionship endures. Fact 27. The smallest known black holes. Not all black holes are enormous. Some are just a few times heavier than our sun. So small and light that they barely disturb the space around them. These are stellar mass black holes, born from ordinary stars that died young. Though tiny on cosmic scales, their pull is absolute, their power no less complete. A teaspoon of matter from their core would outweigh mountains. And yet, in the dark, they are serene. Simple points of gravity doing exactly what gravity does, holding, curving, and resting in stillness. Astronomers search for them patiently, like listening for a faint heartbeat beneath the noise of galaxies. Each one found reminds us, even the smallest shadows carry the weight of stars. Fact 28. Stellar ghosts across the galaxy. Scattered through the Milky Way, countless stellar black holes drift unseen, the hushed remnants of suns that once burned bright. Astronomers believe there may be hundreds of millions of them, each one a silent grave for a fallen star. They move gently through clouds of dust, through regions of calm light, rarely touching anything at all. Only when their gravity bends a nearby star's light do we glimpse them, a subtle brightening, a soft distortion in the night. They are the stellar ghosts of our galaxy, shaping it without being seen. If you could listen closely enough, you might hear their slow, gravitational hum, the heartbeat of the Milky Way, pulsing in silence through the dark. Fact 29. The X-ray whispers of accretion. When gas drifts too close to a black hole, it begins to spiral inward, heating as it goes. This glowing whirlpool is called an accretion disk, and though the black hole itself remains invisible, the gas sings in light we can detect. X-rays, invisible to our eyes but clear to our instruments, reveal this process. Soft, flickering whispers that tell us a hidden companion is feeding. The radiation doesn't come from inside the hole, but from the edge, the last place matter exists before it vanishes. It's a farewell song, a brief flare of brightness before the quiet. By studying these X-ray murmurs, scientists trace the rhythm of unseen giants. In the language of light, even darkness finds a voice. Fact 30. How we find what cannot be seen. Finding a black hole is a little like tracking wind by the movement of leaves. We never see the thing itself, but we notice its influence. Stars orbiting an empty point, light bending strangely, gas vanishing without trace. Telescopes tuned to radio, infrared, and X-ray wavelengths gather the faintest hints of their existence. Mathematics does the rest, mapping the invisible through precision and patience. Each detection is a small triumph of imagination, proof that even in total darkness, truth can shine. So when we say, "We've seen a black hole," what we truly mean is that we've seen its touch, the quiet marks it leaves upon the universe. And with each one found, the cosmos feels a little more complete. Fact 31. The titans at galactic centers. Every large galaxy carries a secret at its core, a single black hole millions or even billions of times more massive than our sun. These are the supermassive black holes, the quiet anchors of galaxies. Around them, billions of stars orbit, in elegant harmony, their paths shaped by an unseen weight. No one knows exactly how these titans formed. Some may have grown from the seeds of smaller black holes, merging and feeding over eons. Others might have been born vast in the early universe, when matter flowed freely and time was young. Whatever their origin, they are patient, steady hearts of gravity. Through them, galaxies hold their form, vast spirals balanced by a single point of stillness. Fact 32. The heart of the Milky Way. At the center of our own galaxy lies one such giant, Sagittarius A. It rests 26,000 light-years away, hidden behind clouds of interstellar dust. Though invisible to the eye, it reveals itself through the dance of nearby stars. Small, bright suns, racing in tight, swift orbits around an empty space. From their motion, astronomers have measured the mass of the invisible, about 4 million suns, compacted into a region no larger than Mercury's orbit. Sagittarius A does not feed often, but when it does, gas and dust flare gently, glowing in radio and X-ray light. Our galaxy's heart beats slowly, quietly, as if dreaming. And every star we see in the Milky Way moves to its silent rhythm. Fact 33. Sagittarius A, the silent giant. Unlike the roaring quasars of distant galaxies, Sagittarius A is calm, a gentle sleeper in the night. Occasionally it stirs, drawing in a wisp of gas or a wandering particle, releasing a brief shimmer before returning to rest. Its hunger is light, its patience infinite. We have captured its portrait through the Event Horizon Telescope, revealing a golden ring of light around a dark shadow, the first glimpse of our galaxy's hidden heart. It doesn't rage or consume. It simply is, serene, balanced, and timeless. To think that everything we see in the Milky Way, every star and nebula, quietly revolves around this peaceful darkness, is to feel the universe breathing, slow, eternal, and utterly calm. Fact 34. How galaxies grow around them. It may seem that black holes form within galaxies, but in truth, galaxies may have grown around their black holes. In the early universe, when clouds of gas gathered and cooled, the pull of these dark centers gave shape to the first spirals and clusters. Stars were born, lived, and died, all while circling a quiet gravitational core. Astronomers have found a strange harmony between a galaxy's size and the mass of its central black hole. The larger the black hole, the greater the galaxy that surrounds it, as if both grew together, feeding from the same cosmic cradle. In this way, every shining collection of stars carries a hidden partner, darkness at its heart, guiding the dance of light. Fact 35. the dance between stars and shadows. Though we often imagine black holes as destroyers, they are in many ways sculptors of galaxies. Their gravity stirs clouds of dust and gas, shaping the regions where new stars are born. They feed on some material, but their influence helps organize the rest, creating a delicate balance between formation and silence. Around supermassive black holes, stars move like dancers around a calm conductor, each orbit tracing the rhythm of unseen power. Their paths reveal not chaos, but choreography. Even destruction in this quiet place becomes part of the pattern, a slow waltz of birth, death, and rebirth. The universe, it seems, does not waste a single motion. Everything, even shadow, contributes to the grand design. Fact 36. Feeding on cosmic gas. Sometimes, the giants awaken. Streams of interstellar gas, drawn by gravity, spiral inward toward the black hole's mouth. Friction and compression heat the gas until it glows, forming an accretion disk, a luminous whirlpool brighter than any star. For a short while, this light can outshine the entire galaxy. But feeding is never violent. It is a slow, patient drift, particles circling closer with each revolution. Some of the energy escapes as radiation or as slender jets of plasma that pierce the surrounding void. And then, the meal ends. The glow fades. The black hole returns to quiet. Even in hunger, the universe moves gently, a rhythm of nourishment and rest, light and silence intertwined. Fact 37. Jets that stretch across light years. When a supermassive black hole feeds, not all of the matter disappears within. Some of it, twisted by magnetic fields and spinning at near the speed of light, escapes along the poles in narrow streams of plasma, relativistic jets that pierce the darkness. These jets can extend for thousands, even millions of light years, glowing faintly as they travel through space. From afar, they look like cosmic lighthouses, beams of energy marking the places where gravity meets electricity and light. They do not destroy. They illuminate, enriching the galaxies they touch with heat and radiation. Each jet whispers a reminder, even from the deepest shadow, the universe finds a way to shine. Fact 38. The weight of billions of suns. Supermassive black holes can be almost beyond comprehension. Some contain the mass of a few million suns, others the weight of tens of billions. Imagine that. Billions of stars, their light, their heat, their very atoms, all condensed into a single, invisible point. These colossal beings shape not only their galaxies, but the rhythm of the cosmos itself. They are gravitational anchors, stabilizing the swirls of countless worlds and dust clouds. And yet, despite their power, they rest in utter stillness, influencing all without sound or movement. They remind us that strength can exist in silence, that the greatest forces in the universe often whisper rather than roar. Fact 39. Ancient quasars and cosmic dawn. Billions of years ago, the universe glowed with strange new light, the radiance of quasars. These were young, ravenous black holes at the centers of newborn galaxies, feeding furiously on gas and dust. Their accretion disks burned brighter than 1 trillion suns, outshining every star around them. Through these brilliant beacons, we see the early cosmos, its fog thinning, its first galaxies forming. Each quasar is a message from the universe's youth, carried to us across eons of darkness. When their hunger faded, they calmed, becoming the quiet giants we see today. Even now, their ancient light drifts through space, a reminder that creation itself once glowed from the heart of shadow. Fact 40. The slow heartbeat of a galaxy. Galaxies breathe in patterns too vast for us to see. At their centers, the supermassive black holes pulse in long, slow rhythms, not of sound, but of gravity and light. When gas drifts inward, the heart of a galaxy brightens. When it rests, the glow fades again. This rise and fall may take millions of years, yet it feels steady, patient, alive. Our own Milky Way center, Sagittarius A, follows this quiet pattern. It feeds only occasionally, sending out soft flares that ripple through clouds of gas like distant echoes. To the stars around it, those pulses are ancient and familiar, a reminder that even the largest hearts in the cosmos beat softly, in time with the rhythm of creation itself. Fact 41. The missing middle. Between the small, stellar black holes and the colossal supermassive ones, there should be a middle class. Yet few have been found. These are the intermediate black holes, objects hundreds or thousands of times the mass of our Sun. They are rare, elusive, and difficult to detect, hidden in the quiet corners of space where light seldom stirs. Astronomers call them the missing link in cosmic growth. Perhaps the children of the first stars, or the seeds that grew into the giants at galactic centers. They may dwell in globular clusters or drift through the dim outskirts of galaxies, unseen but shaping everything around them. To find one is like catching a shadow moving in moonlight, rare, brief, and quietly profound. Fact 42. Clues in star clusters. The best hints of intermediate black holes come from the densest places. Globular clusters, where hundreds of thousands of stars crowd together like luminous grains of sand. There, some stars move too fast, as if drawn by an unseen weight at the cluster's center. Through these motions, scientists infer a hidden mass, perhaps a black hole 1,000 suns heavy. No image confirms it, only gravity's delicate fingerprint. And so the search continues, guided by patience and wonder. In those quiet spheres of starlight, where time seems ancient and still, the universe may be keeping one of its oldest secrets, a bridge between the small and the vast. Fact 43. A bridge between the small and the vast. Intermediate black holes are the bridges of the universe, links between the quiet deaths of single stars and the majestic giants that rule galaxies. They might form when many stellar black holes merge over long, patient ages, or when dense clusters collapse together under their shared gravity. Too heavy to be born from one star, too light to hold a galaxy, they linger in between, rare, graceful, and quiet. Each one is a halfway heartbeat in the cosmos, marking the slow evolution of gravity itself. To find them is to glimpse growth and progress, the universe caught in mid-breath, becoming something greater than it was a moment before. Fact 44. How they might grow. Imagine a cluster of young stars packed close together, their light overlapping like lanterns in fog. As some of them die, their cores collapse into small black holes. Over time, those dark seeds drift toward the center of the cluster, pulled together by mutual gravity. Eventually, they merge, softly, steadily, forming one larger being. Gas and dust feed the new black hole, and it grows heavier with every passing age. Given enough time and enough material, this middleweight could one day become supermassive, anchoring a newborn galaxy around itself. It is the universe's patient method, slow accretion, gentle gathering, showing that even in darkness, creation prefers the art of accumulation. Fact 45. When galaxies merge, so do their shadows. Galaxies are never still. Over billions of years, they drift toward each other, their stars swirling and mingling in vast, slow collisions. At each galaxy's center waits a supermassive black hole, and when the galaxies meet, those giants begin a long spiral toward one another. They circle closer with each orbit, stirring ripples through space-time, waves that stretch across the cosmos. When they finally merge, two shadows become one, releasing a final pulse of gravitational music before settling again into silence. From that union, a new galactic heart is born, larger, calmer, timeless. Even in collision, the universe finds its balance, turning chaos into symmetry and sound into stillness. Fact 46. The quiet centers of dwarf galaxies. Not every galaxy is vast and luminous. Some are small, faint, and ancient. Dwarf galaxies, like delicate clusters of starlight adrift in endless night. Yet even these humble galaxies often carry a black hole at their heart, smaller than the titans of spirals, but still powerful enough to hold their stars together. Their presence suggests that black holes and galaxies have always grown side by side, no matter the scale. When astronomers look closely, they find stars moving in curious ways, a sign that something unseen and heavy sits in the center, keeping time. Even the smallest galaxies, it seems, need a quiet anchor, a dark heart that hums softly beneath their fragile light. Fact 47. The elusive observations. Finding these hidden black holes is an act of patience. Their galaxies are dim, their signals faint. Sometimes, astronomers detect a sudden flicker, a soft X-ray burst, a swirl of radio waves, clues that matter is falling inward for just a moment before the darkness swallows it whole. Other times, they trace the paths of stars with impossible precision, watching for the subtle tug of gravity that betrays a hidden mass. It's like watching a candle flicker in the wind and guessing the size of the unseen hand that moved the air. Each new discovery adds one more piece to the quiet puzzle, a reminder that even what we can't see still shapes the story of the cosmos. Fact 48. Ripples that reveal their existence. When two black holes meet and merge, they do not cry out. They send ripples through space-time itself. These gravitational waves travel outward like vibrations through an invisible sea, stretching and compressing the very fabric of existence. We cannot see them, but our instruments can feel their rhythm, delicate tremors from billions of light years away. Every wave tells a story of two objects spiraling together, of mass turning to motion, of energy released without a sound. Through these ripples, we confirm what once seemed myth, black holes colliding in perfect silence. It is gravity's soft music, played on the strings of the universe, a lullaby written in motion and time. Fact 49. The mystery of the middleweights. Despite years of searching, the intermediate black holes remain ghosts among ghosts. Astronomers see their traces, a faint ripple here, an odd orbit there, but rarely a direct sign. It's as though the universe has hidden them in its quietest folds, letting only the smallest clues escape. Why are they so few? Did they vanish, merging into giants? Or are they waiting, still and invisible, between the galaxies? Perhaps the answer lies not in what we see, but in what we feel, in the subtle pull of gravity where no light shines. The search continues not with haste, but with reverence, for even unanswered questions have a beauty of their own. Fact 50. The hunt that never ends. Every year, new instruments rise to the task of finding these hidden beings. Space telescopes gaze into the deep infrared. Radio observatories trace whispers of motion, and detectors listen for the faint tremors of colliding masses. Each signal adds to the story, not a conclusion, but another thread in the fabric of knowing. Scientists, Like dreamers, follow these trails with quiet patience, knowing that discovery is often less about finding and more about understanding the path itself. Somewhere, in the dim light between galaxies, the universe keeps its calm secrets, waiting for those who listen closely enough to hear them breathe. Fact 51. Black holes born before stars. Before the first suns ever burned, the cosmos was a sea of energy and matter, thick, hot, and young. In those early moments, gravity gathered small ripples of density, pulling them tighter until some collapsed entirely. These may have been the primordial black holes, born not from dying stars, but from the birth of the universe itself. Tiny and ancient, they might still drift through the vastness, quiet and cold, their masses ranging from mountains to worlds, their ages nearly as old as time. If they exist, they are relics of the first dawn, echoes of creation itself, still wandering through the dark, unseen, but forever present. Fact 52. Quantum seeds of darkness. At the dawn of time, the universe was a restless ocean of energy. Tiny fluctuations shimmered in the quantum foam, brief, flickering irregularities that would one day become galaxies, stars, and worlds. But in some places, those ripples may have been strong enough to collapse immediately, forming black holes the size of atoms, each carrying immense mass. These are called quantum or primordial seeds, remnants of the first moments after the Big Bang. Invisible and ancient, they may drift unnoticed through space, tiny distortions in reality itself. Their gravity is faint, their existence uncertain, yet they remind us that even the smallest imperfection in the beginning might still echo through eternity. Fact 53. Could they make up dark matter? Much of the universe is missing from our sight. We call it dark matter, the unseen mass that holds galaxies together, the invisible glue that shapes the cosmic web. Some scientists wonder if this hidden matter could be made of primordial black holes, tiny and cold, scattered like grains of dust through the vastness of space. If so, we would never see them directly, only their collective pull on the galaxies that spin and drift. It's a haunting thought that the mystery of dark matter might not be new at all, but something ancient, a quiet population of invisible stars born before light itself. The universe, in its darkness, may simply be remembering its earliest dreams. Fact 54. Smaller than atoms, heavier than mountains. Imagine holding a black hole the size of a grain of sand, so small it could slip through your fingers, yet so heavy it outweighs an entire mountain range. Such micro black holes, if they exist, would warp the space around them so tightly that even light would curl back in. They would pass silently through matter, leaving only the faintest whisper of gravity behind. Most would have evaporated long ago, fading into the quiet hum of the cosmos. But if even one remains, it would be among the oldest travelers in existence, a relic of the universe's first breath, drifting endlessly between the stars. Fact 55. The evaporating ones. Though black holes seem eternal, even they slowly disappear. Physicist Stephen Hawking discovered that quantum effects near the event horizon allow black holes to lose energy, a faint, ghostly process we call Hawking radiation. It happens so gently that for large black holes, the change is imperceptible, taking far longer than the age of the universe. But for the smallest ones, this evaporation happens more quickly. As they lose mass, they grow hotter, brighter, and more intense, until, in their final moments, they vanish in a quiet burst of energy. No explosion, no sound, just a sigh of light into the dark. It's as if the universe reclaims its borrowed matter returning it softly to the sea of creation. Fact 56. Hawking radiation's gentle glow. Hawking radiation is not like the light of stars. It is more like warmth itself, escaping from emptiness. At the edge of a black hole, virtual particles are born in pairs. One falls inward, the other drifts free, carrying energy away. Over unimaginable spans of time, this steady leak causes the black hole to shrink. It is a slow fading, like embers cooling after a fire. For a black hole the mass of our sun, the process would take far longer than the current age of the cosmos. Yet still, it happens. Constant, inevitable, serene. Even the darkest objects in existence are not exempt from impermanence. In the end, everything glows, even the night itself. Fact 57. The whisper of quantum evaporation. If we could watch a tiny black hole fade away, we'd see its light quicken as it shrinks. The glow would shift from invisible radiation to bursts of higher and higher energy until it ends in a flash too brief for the human eye to perceive. This final flicker is sometimes called a quantum whisper, the last message from a dying horizon. It speaks of balance, creation and dissolution, expansion and return. Nothing is truly lost, only transformed. The energy once locked in gravity becomes motion, warmth, and possibility again. And in that quiet exchange, the universe keeps its endless rhythm. Inhale, exhale, forever. Fact 58. Micro black holes in the early universe. In the universe's first seconds, when temperatures were beyond measure and matter moved faster than thought, there may have existed micro black holes, so small they could fit inside an atom, yet so dense they bent reality around them. They would have flickered into being where energy gathered too tightly, brief sparks of gravity in a storm of creation. Most would have evaporated long ago, vanishing in soft flashes of Hawking radiation. But a few might still wander the cosmos, tiny, cold, and nearly eternal. They leave no trail of light, only the faintest pull on space itself. If they exist, they are time's oldest travelers, echoes of a universe still learning how to form. Fact 59. The theories beyond the standard model. Black holes challenge every boundary of physics. Where gravity and quantum mechanics meet, the equations falter, hinting that something deeper must lie beneath. Scientists speak of quantum gravity, of hidden dimensions, of strings vibrating at the smallest scales, attempts to stitch together a picture of the whole. Some theories suggest black holes might not hold singularities at all, but loops or bridges to other regions of space-time. Others imagine that information, instead of being lost, is quietly preserved in subtle ripples of radiation. Each idea is both science and poetry, a way of listening to the universe when it speaks in riddles. And in that mystery, curiosity becomes its own kind of light. Fact 60. The edge, where physics breaks. At the heart of a black hole, our understanding dissolves. Equations stretch toward infinity. Time and space collapse into something neither can describe. It's here that human knowledge reaches its limit. Not a wall, but a fog, soft and vast. Physicists stand at this boundary, tracing faint clues that may one day reveal what lies beyond. Perhaps a new law of nature waits there, something that unites the small and the immense, the particle and the cosmos. Until then, we simply watch the shadows, learning from the way they move and the way they fade. And the silence at that edge feels less like an ending and more like an invitation. Fact 61. The spinning ones. Kerr black holes. Most black holes don't rest in stillness. They spin, born from collapsing stars that once turned through space. They keep that rotation forever, twisting the very fabric of reality around them. These are called Kerr black holes, and their spin changes everything. Instead of a simple point of no return, their space-time is shaped like a whirlpool, a region where everything, even light, is caught in the flow. Closer in, the pull becomes irresistible, dragging all motion toward the horizon. Yet this spin also grants beauty, a delicate symmetry, a cosmic dance that bends both time and light in elegant spirals. To orbit one is to move through a place where space itself twirls endlessly, a silent waltz in the dark. Fact 62, dragging space around them. A rotating black hole does more than pull. It drags space-time itself along. This effect, called frame dragging, means that near the black hole, even if you stand still, you must turn with it. Space twists, time curves, and the universe itself seems to swirl. Around a Kerr black hole lies a region known as the ergosphere, where nothing can remain motionless. Here, energy can be extracted from rotation, theoretically allowing a traveler to borrow power from the spin itself. It's a graceful paradox: motion born from gravity, energy drawn from silence. The black hole spins endlessly, and the universe moves gently with it. Fact 63. Energy from rotation. Within the ergosphere, physics allows for something remarkable. A process imagined by Roger Penrose, where matter can fall into a black hole and release more energy than it carried in. It's called the Penrose process, a soft miracle of mathematics. If perfected, such an exchange could, in theory, power civilizations, drawing light from darkness, motion from stillness. No machine has yet harnessed it, but nature already does. Jets of plasma shooting from galactic centers may be powered by these same graceful mechanics. It's a reminder that even in the blackest night, there are quiet engines of brilliance, turning endlessly, unseen, lighting the universe from behind the veil. Fact 64. The Penrose process. Stealing spin. In the swirling zone around a spinning black hole, energy does not simply fall inward. It can also escape. Roger Penrose imagined this long ago. A particle entering the ergosphere could split into two, one piece falling into the black hole, the other flying free with more energy than before. This gentle theft, known as the Penrose process, shows that even a black hole's rotation can give something back to the universe. The energy doesn't come from light or matter, but from the spin itself, a graceful exchange between motion and gravity. Though no one has witnessed it directly, we see hints of its truth in the glowing jets that stretch from galactic centers, proof that even darkness can share its strength. Fact 65. Charged black holes and Reissner-Nordstrom mysteries. Some black holes, at least in theory, may hold an electric charge. Unlike the spinning Kerr black holes, these are Reissner-Nordstrom black holes, defined by both gravity and electricity's subtle pull. Their presence adds complexity. Two horizons instead of one, each marking a different boundary between what escapes and what remains trapped. Charged black holes would repel or attract particles differently, shaping the space around them in new, delicate ways. Yet in reality, such charges likely fade as quickly as they form, neutralized by the sea of opposite charges drifting through the cosmos. Still, the equations describing them are beautiful, a quiet blend of force and symmetry, a glimpse into how the universe balances its opposites in perfect stillness. Fact 66. Twin horizons and electric fields. Within a charged or rotating black hole, there can exist not one, but two horizons. An outer one, the event horizon, and an inner, hidden boundary deep within. Between them, strange things can occur. Time can loop, energy can oscillate, and electric fields can shimmer like invisible rain. These twin horizons are fragile. Quantum effects may blur or destroy them entirely. But their existence reminds us that black holes are not singular holes at all, but layers of space and time, folded together like the pages of a silent book. Each horizon marks a story's edge, a moment where the laws of nature pause and the unknown begins to speak softly from within. Fact 67. Rotating giants at galactic cores. At the heart of nearly every galaxy lies a black hole that spins, slowly, steadily, endlessly. These rotating giants twist space itself, their rotation setting the rhythm of their surroundings. Clouds of gas swirl into glowing disks. Stars drift in curved orbits, and powerful magnetic fields spiral outward in response. Some rotate almost as fast as the laws of physics allow, their edges moving close to the speed of light, pulling space-time into a graceful whirlpool. That spin can last for billions of years, unchanged and serene. It's a cosmic balance, gravity and rotation, weight and motion, light and shadow, all circling together like a slow, eternal dance. Fact 68. The ring, singularity's gentle curve. In a rotating black hole, the singularity isn't a point, it's a ring. Spinning flattens the heart of gravity into a circular curve, a smooth, invisible halo made of infinite density. Mathematically, this ring singularity is hollow, a tunnel through curved space. Some theories even whisper that if one could pass through its center, you might emerge elsewhere, perhaps in another universe entirely. It's a poetic thought, though likely impossible in practice, for the forces near that ring are far too great for matter to endure. Still, it offers a softer image, not a crushing point, but a curve, a loop that suggests continuity, that even in destruction, geometry finds elegance. Fact 69. When rotation calms the collapse. Spin can be a form of resistance. When a star collapses, its rotation can slow the fall, spreading the energy across space and time. The faster it spins, the more it pushes back against gravity's pull, delaying its final surrender. In a way, rotation is the star's last act of defiance, a gentle turning that prevents an instant collapse, giving rise instead to the graceful form of a rotating black hole. This is nature's quiet symmetry, motion balancing weight, grace balancing power. A black hole's spin isn't violence, it's preservation, a soft reminder that even the strongest forces in the cosmos seek equilibrium. Fact 70. The elegant equations of relativity. Behind every black hole lies a tapestry of mathematics so precise it borders on poetry. Einstein's field equations of general relativity describe how matter tells space how to curve, and space tells matter how to move. From those equations, black holes arise naturally, not as oddities, but as inevitable harmonies within the fabric of reality. The simplest solution gives the still, spherical black hole. Add spin or charge, and the shapes evolve into whirling vortices of curved geometry. Each form obeys the same cosmic rhythm, a balance of mass, energy, and the quiet bending of time. These equations don't just predict gravity's strength. They sing of the universe's design, elegant, patient, and endlessly complete. Fact 71. When two darknesses meet, across the universe, black holes are never truly alone. Drifting through galaxies, they sometimes find one another, drawn by mutual gravity. For millions of years, they orbit slowly, spiraling closer and closer, their motion so gradual it could lull even time itself to sleep. As they near, their gravitational fields intertwine, two wells becoming one deep, smooth curve. Matter caught between them glows, twisting into brilliant arcs before vanishing. Their approach is not violent but rhythmic, like two tides merging into a single wider sea. When they finally touch, the universe trembles, and silence gives way to the faintest ripple through the fabric of space-time. Fact 72. The dance of death and creation. As two black holes circle, their orbits decay with every turn, energy leaking away as gravitational waves, ripples that travel through space itself. Each wave carries the story of their motion, their speed, their mass, their inevitability. The dance quickens, slow, then faster, then a single, soundless collision. In that moment, they merge into one, their horizons blending like ink and water. The result is a single, larger black hole, calmer than either that came before. Out of collapse comes unity. Out of motion comes stillness. And though the universe barely stirs, its very structure has been changed, gently, forever. Fact 73. Gravitational waves in the fabric of night. When two massive bodies move together, stars, neutron remnants, or black holes, they stretch and squeeze the fabric of space-time itself. These are gravitational waves, silent ripples that travel outward from the source, carrying energy across the universe. They are unimaginably faint, passing through everything without resistance, yet they hold the rhythm of creation within their motion. Each wave changes the distance between points in space by less than a fraction of an atom, and yet that subtle trembling tells a story billions of years old. The universe hums with these vibrations, a deep, cosmic music that has always been playing, only now beginning to be heard. Fact 74. The LIGO Symphony. In 2015, humanity finally heard the echo of two black holes colliding. The LIGO observatories, twin instruments built to measure the tiniest shifts in space itself, detected a ripple that had traveled for over 1 billion years. It lasted less than a second, a faint chirp, rising and fading. But in that whisper lay proof of Einstein's predictions. It was a soft confirmation that the universe speaks not only in light, but in waves. Since then, dozens more have been heard. Black holes merging, stars collapsing, all contributing their notes to this quiet, ongoing symphony. Each detection is like hearing the heartbeat of space, steady and serene, a reminder that even in darkness, there is motion beyond measure. Fact 75. How we hear their collisions. Gravitational waves do not make sound in space, but when converted into frequencies, we can perceive they resemble music. Soft, ascending tones that rise in pitch as two black holes spiral inward. These cosmic songs last only moments, yet they carry the weight of stars, the memory of entire galaxies. To listen is to witness time itself moving, the energy of motion translated into the language of vibration. Every collision adds a new note to the universe's melody, a lullaby written in gravity and silence. In each faint chirp, we hear proof that the cosmos is not still. It breathes, it sings, and it remembers every step of its eternal dance. Fact 76. The energy of merging giants. When two black holes collide, their meeting releases an astonishing burst of energy. For a brief instant, more power than all the stars in the visible universe combined. Yet this release is not fiery or loud. It comes as pure gravitational energy, waves expanding outward at the speed of light. A portion of their combined mass, sometimes several suns' worth, is converted entirely into motion through space-time. No explosion, no debris, no light. just ripples that travel forever, carrying the quiet echo of creation's most powerful embrace. Even in its greatest strength, the universe prefers to whisper. Fact 77. Ripples that cross the universe. Those gravitational ripples never fade completely. They pass through galaxies, clouds of gas, and even our own bodies, stretching and relaxing space as they move. We do not feel them. They are far too small, but they are always there, soft waves rolling endlessly through the deep. Each one tells a story, where it began, how massive the merging black holes were, how fast they spun before becoming one. By reading these waves, scientists can trace events that happened billions of years and trillions of miles away. The universe, it turns out, has always been speaking. We have only just learned to listen. Fact 78. After the collision, one remains. When the dance of two black holes ends, the result is peace. The new black hole that forms quivers briefly, a final, ringing note as it settles into shape. Then all is still again. It is larger than either parent, heavier, smoother, its event horizon now calm and perfect. The surrounding space quiets, like a pond returning to stillness after a single drop. The ripples move on, the story spreads outward, and what remains is silence, not an ending, but a balance restored. In that calm aftermath, the universe rests for a moment before beginning another gentle cycle of motion and return. Fact 79. The birth of a new horizon. When two black holes merge, a new horizon is born. Smooth, round, and perfect. The wrinkled surfaces of the old horizons blend into one, and for a fleeting instant, space itself vibrates like a struck bell. This moment, called the ring down, is when the newborn black hole settles into silence. Its waves grow weaker, its edges smooth out, and its energy fades into the universe as a final ripple. What remains is a single seamless sphere, a region of space so calm that nothing can disturb it. It is both a grave and a cradle, the ending of two lives and the beginning of another. A dark star born from union, not from death. Fact 80. The cosmos, gently ringing. After a merger, the surrounding universe quivers with soft resonance. Physicists describe this fading vibration as the ringing of space-time, a pure tone carried on waves of gravity. It doesn't make sound in the ordinary sense, yet if translated to audio, it becomes a deep, musical note, a cosmic hum that slowly fades into stillness. Each black hole has its own unique tone, determined by its mass and spin. By listening to that tone, scientists can tell exactly what kind of black hole was born. It is a kind of fingerprint, a song sung only once. Even after the event has ended, the memory of motion remains, echoing faintly through the fabric of the cosmos. Fact 81. Shadows captured by light. For centuries, black holes existed only in theory, mathematical ghosts in Einstein's equations. Then in 2019, humanity finally saw one. Using the combined power of radio telescopes around the world, the Event Horizon Telescope captured the shadow of the black hole in galaxy M87. What appeared was a glowing ring of light surrounding a dark center, the place where light itself falls away. It was not an artist's dream, but a real image, proof that these silent giants truly exist. That faint orange halo, seen across 55 million light-years, was more than a photograph. It was a window into the unknown, a portrait of gravity itself, drawn in light and silence. Fact 82. How we see the invisible. A black hole cannot be seen directly, yet we glimpse it through what surrounds it. Light bends near the event horizon, curving back toward us in circles of gold. Gas heated by friction glows brighter than any star, tracing the edge where reality folds inward. Astronomers combine signals from telescopes spread across the Earth, each collecting faint whispers of radio light. And together, they form a single planet-sized eye. This technique, called interferometry, lets us see the unseeable. What appears as a ring is not the hole itself, but light bent around it, a reflection of gravity's artistry, painted in radiance and shadow. Fact 83, the first portrait of darkness. The image of M87's black hole, released in 2019, was more than a photograph. It was a revelation. At its center, a soft, dark oval, the shadow where light cannot return. Around it, a ring of fire, not burning, but bending, as photons orbit before falling inward. This glow comes from matter spiraling near the event horizon, compressed and heated to billions of degrees. To see it is to watch gravity itself sculpt light into form. That blurred, golden circle is ancient light, born long before humanity learned to dream of the stars. It reminds us that even the darkest places can reveal beauty if we learn to look with patience and wonder. Fact 84. The heart of our own galaxy. Revealed. 3 years later, in 2022, the same global network captured another image, this time of Sagittarius A, the black hole at the center of our Milky Way. Smaller and closer than M87's giant, it flickers like a candle in motion, its ring shifting as gas orbits in minutes, not days. The image was harder to take. The hole's quick heartbeat blurred its outline, but still the familiar shape appeared. A dark core, a glowing edge, a perfect symmetry. To gaze upon it is to see home from a new perspective, the quiet heart around which every star, every world, and every breath we take gently turns. Fact 85. Light that circles twice. When light passes near a black hole, it does not simply vanish. Instead, it bends, curved by the immense gravity that pulls even photons from straight paths. Some rays circle once, others twice, each revolution weaving a fainter, thinner echo of the glowing ring. These delicate arcs form what scientists call the photon sphere, a shimmering halo where light orbits endlessly before escaping. If our eyes could see it directly, the black hole would appear surrounded by infinite repeating rings, each one a reflection of the universe behind it. It is gravity's mirror, the cosmos folding back upon itself, light and darkness entwined in eternal embrace. Fact 86. Making pictures from echoes. The images we see of black holes are not taken like ordinary photographs. No camera lens could capture such distances or faint signals. Instead, radio telescopes scattered across the planet collect waves of energy, each one a small piece of the larger pattern. Computers combine those signals, timing them with atomic precision, rebuilding the picture bit by bit, a tapestry woven from delay and phase. This process turns whispers into vision, transforming radio hum into a portrait of the invisible. Every pixel in those images represents both patience and faith. Faith that nature keeps its shape, and patience enough to wait for light's faintest return. Fact 87. The dream of filming the dark. Someday, we may not only see black holes, but watch them move. Their glowing rings, flickering and swirling as matter drifts inward. Their shapes bending as time stretches near the edge. Scientists are already building telescopes capable of this. Machines that will record light as it dances through warped space. A real-time view of a black hole could show the living heartbeat of gravity, waves of brightness rising and fading like breath. To watch such a film would be to glimpse time slowed almost to stillness, a cosmic ballet performed in silence, reminding us that even where nothing escapes, motion never ceases. Fact 88. The edge of forever. The event horizon marks the boundary between what can return and what cannot. From the outside, it looks like a surface, but it isn't really a thing you could touch. It's a place in time where escape becomes impossible, where every path, even that of light, curves inward toward silence. To an observer far away, anything falling toward the horizon seems to slow, its motion stretching endlessly, its light fading to red and then to black. But to the falling object itself, the journey continues smoothly inward. Two perspectives, both true, divided by the simple fact that time bends here. At this edge, the universe seems to pause, an infinite stillness that conceals an endless fall. Fact 89. The possibility of wormholes. Einstein's equations allow for strange solutions. Tunnels through space-time called wormholes, bridges that might connect distant points or even separate universes. Some physicists believe that rotating black holes could form such pathways, their ring-shaped singularities serving as hidden doorways through the void. But these paths, if they exist, would be fragile, collapsing faster than light could pass through. They belong, perhaps, more to the language of dreams than to physics as we know it. Still, the idea endures because it speaks to a deep truth. The cosmos is not closed or cruel, but full of potential routes yet unseen, like quiet corridors in the house of infinity. Fact 90. Where time stands, still close to a black hole, time slows for everything. A clock near the horizon ticks more slowly than one far away. From a safe distance, an observer would never see something cross the edge. To them, it seems frozen forever, caught between moments. This is gravitational time dilation, the bending of time itself by the weight of mass. It means that, near a black hole, seconds can stretch into centuries, and yet, for the traveler falling in, nothing feels unusual. They move forward, unaware that their future has already left the rest of time behind. It's a haunting thought, that eternity is not a place, but a perspective. Fact 91. Beyond the horizon. What lies inside a black hole remains hidden from all observation. No signal escapes, no light returns. Yet theory allows us to imagine a descent through stretching space and slowing time, where matter is compressed into forms beyond comprehension. For the falling traveler, the journey would seem brief and strange. Space would narrow, light would distort, and time itself would lose all shape. Some physicists say all paths lead inevitably to the singularity, a place where density becomes infinite and known physics dissolves. It is the universe's hidden core, a region not of chaos, but of pure geometry, where the fabric of existence folds in upon itself like a sigh. Fact 92. Theories of passage and rebirth. Some theories suggest that what enters a black hole might not end, but be transformed. Quantum physics hints that information, the delicate pattern of everything that falls in, cannot be truly destroyed. If so, perhaps black holes are not final graves, but gateways that translate matter and energy into new expressions of the cosmos. In some models, every black hole could birth a new universe inside it, a small, self-contained realm expanding on the other side of collapse. To imagine this is to soften the fear of endings. For every disappearance might also be a creation, a dark seed flowering silently into something new. Fact 93. The information that remains. The information paradox asks a gentle but profound question. if nothing can escape a black hole, what happens to the details, the history of what has fallen in? Stephen Hawking once believed that it vanished forever, but later wondered if it might be preserved in subtle radiation, encoded at the event horizon like writing on a veil. If true, then the black hole is not a destroyer, but a library written in the quietest ink imaginable, a cosmic archive holding everything it has ever touched. Perhaps someday, the universe will learn to read that script and discover that even in oblivion, nothing is ever truly lost. Fact 94. Hawking's last light. Stephen Hawking spent his life listening to the silence of black holes. Through mathematics, he discovered that even these dark beings could glow faintly, emitting warmth through Hawking radiation, proving that no part of the universe is truly without voice. He showed that black holes are not prisons, but processes, places where matter, time, and energy are woven together, where destruction and creation balance perfectly. His ideas turned fear into fascination and made the abyss a thing of beauty. In his final years, Hawking suggested that information might escape not through light, but through the delicate shimmer of quantum laws, a final whisper from the edge of eternity. His work reminds us, even the darkest questions can illuminate the soul. Fact 95. The holographic horizon. Some physicists believe that everything we experience in 3 dimensions may actually be a projection from a flat surface, a hologram written on the boundaries of space-time. In this view, black holes are the universe's most perfect mirrors. Their event horizons might store every detail of what falls within, encoded like patterns of ripples on the surface of a pond. What seems lost is really written there, just in a form we can't yet read. This holographic principle suggests that all reality, every atom, every dream, may exist as a kind of cosmic reflection, an intricate illusion of depth, painted gently upon the skin of space. Fact 96. The universe as reflection. If the holographic idea is true, then the universe we see, the stars, the galaxies, ourselves, might be the shadow of a deeper truth. Every particle, every black hole would be part of a grand, projected pattern, light and gravity telling the same story in 2 languages at once. Perhaps we are the image of a higher dimensional world, watching its reflection move in time. And black holes, those silent wells, are the clearest mirrors of all, showing us that what we call inside and outside are merely 2 sides of one infinite whole. To look into their darkness is to glimpse the universe looking gently back. Fact 97. The keepers of the distant future. Long after the stars fade and galaxies grow dim, black holes will remain, silent guardians of the dark. In that degenerate era of the universe, when suns have burned out and atoms drift apart, only these quiet giants will endure. They will wander through an ever-expanding void, their gravity faintly tugging on what little matter is left. For trillions upon trillions of years, they will outlast everything, their horizons unchanged, their pull unbroken. When all else has gone cold, black holes will still hold memory, not in words or light, but in presence. They will be the universe's last structures, the final shapes in a fading dream. Fact 98. The long evaporation. Even eternity has an ending. Through Hawking radiation, black holes slowly lose their mass, a whisper of warmth escaping into the endless dark. For a supermassive black hole, this process may take more than 1,000 trillion years. As they shrink, their glow will rise in pitch, brightening in the final instant before disappearing altogether. One last flash, then silence, No remnant, no ashes, no echo. Just the quiet return of energy to the sea of space. The universe will sigh softly, as if exhaling the final note of a cosmic song that began with light and ends in calm. Fact 99. The Age of Blackness. When the last black hole vanishes, the universe will enter its final act. A realm without stars, planets, or motion. Only the faint shimmer of particles will remain, drifting in infinite stillness. Some call this the heat death of the cosmos, when all energy has been shared and balanced perfectly. No light will shine, no time will change, only an even, eternal quiet. Yet in that stillness, there is peace, for everything that once was still exists in memory, in the ripples and echoes that shape time itself. The universe will not end in fire or in fear, but in serenity, a gentle rest after an infinite journey. Fact 100. The universe dreams of light again. And so, when all things have come and gone, when every atom has drifted and every black hole has released its final sigh, the universe will rest in quiet balance. But even then, the story may not be over. Some theories suggest that in the deep stillness, quantum fields may flicker once more. Tiny sparks, random and free, awakening from the infinite dark. From one such spark, a new expansion could begin. Another Big Bang, another bloom of stars, another chance for wonder to unfold. Perhaps this cycle has happened countless times before, each universe dreaming the next into being, each one born from the fading breath of the last. If so, then black holes are not tombs at all, but seeds, silent, perfect, waiting. In their darkness lies continuity, in their gravity, the memory of light, and in their quiet, the promise that nothing truly ends, it only changes form. The universe exhales and dreams again. And as our journey comes to a gentle close, I hope you found a little peace among the stars tonight. We've traveled together through time and gravity, through silence and creation, through the soft edges of the infinite. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and share what topic you'd love to fall asleep to next. Your curiosity helps guide future voyages through the cosmos. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. For now, let the last echoes of starlight fade. Let your breath slow to match the rhythm of the night, and let go. The galaxies will keep turning. The black holes will keep dreaming. And you are part of that same gentle, endless story. Sweet dreams, traveler, and see you among the stars.